any function which satisfies that Dirichlet condition, okay, speak up, that can be expanded in terms of cosine and sine. It can be exponential, it can be polynomial in this interval, okay? This interval is important. It can be exponential, it can be polynomial, it can be Gaussian function, it can be trigonometric again. That can be expanded in terms of sine and cosine. Let me collect all of this, whatever I took in the series. Okay, what is that? Sine 3x and so on. Okay, so can I take like this? Okay, let me collect all of these things. We call them as a basis in the sense of linear algebra, actually. Basis. Okay, they are a base, am I right? Using them, you can generate any function. I mean, using this cos nx and sin nx. Look at here. This side you can put exponential, you can put polynomial, you can put Gaussian, isn't it? Speak up. I mean, cos nx and sin nx, they are mixing themselves and they are capable of generating any function. Are you know? Speak up. It's one infinite series actually, but it is capable of generating any function. That's why we call them as a basis. Is that okay? Sometimes we call them as basis actually. This set of function, whatever I wrote. Now, there is a very good analogy here. The analogy is you have three basic colors, isn't it? So, what are those? RGB. Oh, it's not looking like red on YouTube. You can mix them in a different ratio. Speak up. You can generate any color whatsoever. You can generate any color in the reverse way. Okay, in the reverse way. Okay, speak up. Oh, my C1, C2, C3 got reverse. Any color can be generated using these three colors. Whatever I'm trying to explain here, any function which satisfies the Dirichlet condition, those are simple. I mean, finite number of maxima, minima, finite number of discontinuity, single valued, those will happen for most of the function, whatever we discuss, okay? It can be written in terms of sine and cosine, am I right? Speak up. So that means I'm trying to say, whatever color you have, okay, that can be generated by mixing whatever color, arbitrary color you take, speak up, that can be obtained by combining these three. Speak up. Can I say like this? I'll just write C1 into this one, this much time like that. Okay, speak up. Plus C2 into this one, plus C3 into this one. Am I right? Speak up. That's what I'm saying here. Okay, I mean, so these three can be it can be understood in two different ways. Okay, one is sine and cosine that can be combined and form any function. RGB, they can be combined in a different ratio. What do you mean by different ratio here? Different coefficient. We call this as linear combination. Okay, what do you mean by different linear combination? Different coefficient actually. Okay, speak up. So sine and cosine, they can be combined in a different ratio. Can I say like this roughly? Okay, speak up. You can generate any function. Okay, like RGB, they can be combined in a different ratio, and you can generate any color. Or in other sense, what I'm saying, whatever the function you take, that can be expanded in terms of sine and cosine. Is that okay? Whatever the color you take, it can be, what do you call, generated using combining these three in a different ratio. Now the question is, okay, I will give this color. Okay, I'll give you this color. When you say that you know how to combine these three and form this color, when you say that one, when you know that C1, C2, C3, when you know in what ratio you need to combine them, isn't it? In the very similar manner, you go back here. When you say, when you know this expansion, when you know this AN, BN, A naught, AN, BN, in what ratio you are mixing sine and cosine. When you know those coefficients, that means you know the expansion of this one. Are you understanding this point? Okay. When you say you know this color in terms of them, or when you say you can generate this color using them, okay, when you know in what ratio you need to mix them, isn't it? In the similar manner, that coefficient play the role of ratio of mixtures actually of the sine and cosine. Okay, but here we have only three bases. Can I say like this? RGB. But here we have infinitely many bases, but they are sine and cosine functions. Very similar thing will happen in case of our vectors. Okay, I'll just keep this one. In the evening, let me explain. Okay, You have your I cap, j cap, k cap. Am I right? Cartesian unit vectors. Okay. You multiply them by ax, ay, az. You can generate any other vector. You can combine I cap, j cap, k cap in a different ratio. You can generate any vector in your 3 dimension, or any vector in 3 dimension can be written in terms of I cap, j cap, k cap. I want you to link these things actually. Okay. I want you to see that algebra, I mean vector algebra here actually. Here we have only 3 bases, again I cap, j cap, k cap. But here we have many bases, okay? But they are sine and cosine. They are not any function, am I right? They are sine and cosine. They are trigonometric sine and cosine function, am I right? Speaker. Very similar. You can analogy, you can drag the analogy. So later, I mean, it will be helpful for understanding linear algebra. I mean, linear algebra is a generalization, okay?